Right, today we're going to talk about radian measure and angles of rotation. So we did an exploration on what a radian measure is, where they come from. But so just real quickly, how many radii, which is plural for radius, does it take to go halfway around the circle? So if we look at this circle, which we talked about the other day, that's the distance for the radius is from A to B. So if I take that distance and wrap it around my circle, that gives us 1 radian, which is about 57.3 degrees. So halfway around our circle, you notice that's 2 radians, 3 radians, and a little bit more. I can't quite get 3.14, but it would be 3.14 radians, which 3.14 you should all recognize as pi. And if we keep taking that radius all the way around, it takes 6 radians and a little bit more, which is 6.28. So 3.14 plus 3.14 is 6.28, or 2 pi radians, which remember we said is like the circumference of a circle, 2 pi r. So 3.14 is halfway around the circle, which is equal to pi. 6.28, which is equal to 2 pi. And we said, is this true for all circles if we change the radius? Yes, because it doesn't matter how big or how small the radius is, you will always get 2 pi all the way around your circle. So degree measurement is one way to describe the size of an angle. Radian measurement can be used for this purpose as well, but it's also useful because it can relate the size of an angle to the length of the arc subtended by the angle. A radian is an unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So what does that mean? So 1 radian is equal to what 1 radius length is equal to. And we also said the other day that 1 radian is about 57.3 degrees. So recall that the circumference of the circle is 2 pi r, therefore 360 degrees equals 2 pi, and 180 degrees is equal to pi. If we want to convert to from degrees to radians, you multiply the degrees by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. When no units of angle measure are specified, so there's no degree symbol, then radian measure is implied. Always keep radian measures in terms of pi's, no decimals. So we're going to convert from degrees to radians. So to convert 500 degrees to radians, we're going to multiply this by pi over 180 because we're using this conversion here. So if I multiply by pi over 180, I have 500 pi over 180. This cancels out, so 50 over 18. If you can't do that in your head, you can use your calculator, or you can use your calculator for the whole thing. 500 divided by 180 and hit the math fraction key. Just do this without the pi so that you can get a fraction. So that gives us 25 over 9, and then you just have to put the pi back in. So we write that as 25 pi over 9. So to convert negative 150 degrees into radians, we multiply again by pi over 180. So when we do that, we have negative 150, divide that by 180, hit the math fraction key, and that gives us negative 5 pi over 6. To convert from radians to degrees, and we know these are radian measures because there's no degree symbol. You always have to label a degree with a degree symbol. We multiply this by 180 over pi. So then your pi's cancel out and you're left with 180 over 10, which is just 18 degrees. Over here, again, same thing, multiply by this 180 over pi. And a good question is, does a radian measure always have pi in it? No. You can have radian measures without pi in it, so that means that they're not always going to cancel out, just to point that out. So we have negative 14 times 180 in the numerator, and then we're going to divide that answer by 15 to get negative 168 degrees. And again, always label degree measures using a degree symbol. Otherwise, it's assumed to be a radian measure, and if it's supposed to be degrees, will be marked wrong. So keep that in mind. You always want to be very careful about how you're labeling. All right. An angle is determined by rotating a ray about its endpoint. The starting position of the ray is the initial side of the angle, and the position after the rotation is the terminal side. The endpoint of the ray is the vertex of the angle. In the coordinate plane, when the vertex of the angle is at the origin and the initial side is on the positive x-axis, the angle is said to be in standard position. An angle in standard position is said to lie in which the terminal side is located. So if we look at these two examples right here, looking at the first example with the positive angle, recall this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, they start from the x-axis and go in the counterclockwise direction. So the positive angle, we would say, lies in quadrant 2 because that's where the terminal side is. For the negative angle, we would say this lies in quadrant 4 because that's where the terminal side is. So if the direction of the angle has a counterclockwise direction, then the angle is positive. Why counterclockwise? Because it follows the quadrants. If the direction of the angle has a clockwise direction, then the angle is negative, such as in these two pictures below. Next, it says to draw each angle in standard form or standard position and determine the quadrant in which the terminal side lies. So for this one, what I would first do is label, since we're using degrees, I would label this as 0 degrees. We know halfway around our circle is 180 degrees. All the way around the circle is 360 degrees. So half of 180 is 90 degrees. So this would be 90, 80, and down here 270. So that would be going the counterclockwise direction. So 220 degrees, we then notice would be in between 180 and 270 degrees. So think about taking half of 90 degrees. Half of 90 degrees would be 45 degrees. So in between 180 and 270, if we take 180 degrees and add 45, that would be 225 degrees. So I know 225 degrees is about right here. So because of that, that tells me that 220 is pretty close to 225, so not quite halfway there, but close. So I'm going to draw my arrow kind of close to that, a little bit closer to 180 degrees. And then you always start at the positive x-axis. It's a positive angle, so we're going to go counterclockwise, and that would be the angle drawn in standard position. Yes, you always need to draw the arrow starting at the x-axis to the terminal side. And then this is in quadrant 3 because that's where the terminal arrow lies. Looking at number 2, 67 degrees. So if this is 0 degrees and 90 degrees, we know 67 degrees is in quadrant 1 towards the 90 degrees up here. So this would be the angle drawn in quadrant 1 in standard position. Negative 135 degrees, so this is 0 degrees. If we go the other direction, clockwise on my graph, I would have negative 90 degrees, negative 180 degrees, negative 270 degrees, and all the way around is negative 360 degrees. So negative 135 would be in quadrant 3, that's down here. So we know this is quadrant 3. Just because we're going the negative direction doesn't mean we change the quadrants. So then for this, 135 would be right in between, so here. And now instead of going counterclockwise, we start at the positive x-axis and go in a clockwise direction for a negative angle measure. 156 would be in quadrant 2. So 156 is going to be closer to down here by the x-axis, so from here to here. So those are our angles drawn in standard position. So now let's do the next ones in standard position, but the difference is instead of using a degree measure, we have a radian measure. So let's think about radians. So we learned that halfway around our circle, so if we start here, this is 0 radians, this is pi, and all the way around our circle is 2 pi. So let's think about the decimals. Pi is a decimal, is 3.14 about. So if 3.14 is halfway around the circle, then 3.14 plus 3.14 is 6.28 would be all the way around our circle. Well, half of pi is pi over 2. So half about of 3.14 would be about 1.5 something. So it's about 1.57, so 1.5, 1.6. So about 1.5, we'll say 7. Actually, use the other color. And then down here, so if we know that 90 degrees is pi over 2, so that would be 1 pi over 2, 2 pi over 2 is pi. This would be 3 pi over 2, which is 270, and then 2 pi. So 3.14 is here, half of that's 1.57. So 3.14 plus 1.57 gives us about 4.71 for 3 pi over 2. So the way that I would look at this is I could put that as a decimal. Pi divided by 15 is equal to about 0.2. So 0.2 is in between 0 and also 1.57. Obviously, it's closer to 0. So for this one, this would be the angle drawn in standard position. So that's in quadrant 1. Another way you could do this is to actually convert the angle to degree measure. So pi over 15 times 180 over pi. The pi's cancel out. So we get 180 divided by 15. So 180 divided by 15 gives us 12 degrees. So that's another way you can find out where the what quadrant you're in and where the terminal side lies. So looking at the next one, if we take the decimal, 4 pi divided by 5 is equal to 2.51. So we know, again, halfway around is pi, or 3.14, and this is half of that, pi over 2, which is 1.57. So we know 2.51 would have to be in quadrant 2, and it's going to probably be a little bit closer to here. And if you're unsure, convert this to a degree measure. So 4 pi over 5 times 180 over pi. Pi's cancel out, so we have 4 times 180, and then we're going to divide that answer by 5 to get 144 degrees. Looking at the next one, we have 8 pi over 7. So 8 pi divided by 7 gives me 3.59, which is bigger than pi. So I know that it's going to be in quadrant 3. But if I'm unsure, multiply this by 180 over pi. So your pi's cancel out in this case. So 180 times 8, and then divide that by 7, and we get about 205.7 degrees. So that tells us we would be somewhere about here. Negative pi over 12, because it's negative, I know I'm going in the clockwise direction. This would be in quadrant 4. So if you think about pi divided by 12, notice it's 0.2. So if the positive direction, we know 0 to pi over 2 would be 0 to 1.57. That's how we know we're going to be down here. So it's very close to the 12 degree one that we had. So if I multiply this by 180 over pi, those would cancel out to leave me with negative 15 degrees. And again, that's why we're starting at the x-axis and going the clockwise direction. So those are for the radian measures in standard position. Now we're going to look at coterminal angles. An angle is coterminal with another angle if they share the same initial and terminal sides. You can find coterminal angles by adding or subtracting one full revolution or any multiple of 360 degrees, which is one full revolution in degrees, or 2 pi radians for if you're in a radian measure. So looking here, we can see that these are coterminal angles. They have the same initial side, which is the positive x-axis, this blue ray right here, and the terminal side, which is this ray right here in quadrant 2. So we would say 120 degrees and negative 240 degrees are coterminal. What if I took 120 degrees and added another 360 to that? That would be 480 degrees. So drawn in standard position, we've gone all the way around our circle 360 degrees plus 120 degrees, and that gives us 480 degrees. I could also take negative 240 degrees and subtract another 360 from that to get negative 600 as another angle measurement. And so if I was graphing that one, I would go in the clockwise direction around once plus the negative 240, which would give me negative 600. So those are all called coterminal. And of course, because you can add or subtract 360 or 2 pi an infinite amount of times, there's an infinite amount of coterminal answers that you can have, or angles, I should say. So for these, it says, for each angle, find 2 coterminal angles. We're going to do one positive and one negative. So to find coterminal angles in degrees, we're going to add 360 degrees, or we're going to subtract 360 degrees from the given angle. So 73 plus 360 gives me 433, and 73 minus 360 gives me negative 287. Of course, these are not the only answers we can have. We could take that 433 and keep adding 360 to get 793 plus another 360, add another 360. These are all going to be coterminal angles to 73 degrees because they're going to have the same starting and same ending side position. And looking at the next one, so negative 46 plus 360 degrees and negative 46 minus 360 degrees. So this gives us 314 degrees and negative 406 degrees. If we are in radians, we want to find coterminal angles in radians, not in degrees. So how do we find them in radians? We want to add or subtract 2 pi. But because this is a fraction, I need a common denominator to add or subtract these. So this is over 1, this is over 7. So I need to multiply this by 7 over 7 to get a common denominator. So this becomes pi over 7 plus, and this would become 14 pi over 7, which allows me then to add the numerator over my common denominator. So 1 plus 14 is 15 pi over 7 is my coterminal angle. Could you change this to a degree measure and then turn it back into radians? You could, but that's more work, and some of these you're not going to have a calculator for, so you need to really be able to add and subtract 2 pi by getting common denominators. So if I had pi over 7 and I wanted a negative coterminal angle, I'm going to subtract 14 pi over 7. So when I subtract 14 pi over 7, I get negative 13 pi over 7. Looking at the next one, we have negative 2 pi over 3. We're going to do the same thing. So we're going to add 2 pi to this for a positive coterminal angle. We need a common denominator, so we're going to multiply that by 3 over 3. So negative 2 pi over 3 plus 6 pi over 3. Then in my numerators, negative 2 pi plus 6 pi are like terms, which gives us 4 pi over 3. So that means 4 pi over 3 is coterminal with negative 2 pi over 3. So if I take negative 2 pi over 3 and instead of adding 6 pi over 3, I subtract 6 pi over 3, which is again really subtracting 2 pi, we get negative 8 pi over 3. So those are all coterminal. Next says, draw the given angle in standard position, find 2 coterminal angles, one positive and one negative, and then that's just repeating what we just said. And then instead of doing 120 degrees, let's do 240 degrees because that picture above had up here that we showed was 120 degrees, so we're going to do 240. So again, if you don't remember where 240 is, you can draw 0, 90 degrees, so 0 degrees, 90 degrees, 180 degrees, 270 degrees. So we know 240 is going to be in quadrant 3. And for the angle that we're drawing of negative, or sorry, not negative, just 240, It's going to be closer to 270. So this would be the angle starting at the positive x-axis going in the counterclockwise direction that we would draw in standard position. If we want the positive coterminal angle, then I'm going to take 240 degrees and add 360 degrees to that, which gives me 600 degrees. So it has the same starting position and same ending position, but we've gone now all the way around 360 degrees plus the 240 gives me 660. So that's, or excuse me, not 660, but 600. So that is my angle drawn in standard position that's coterminal to 240. So let's go ahead and put the terminal side in again and do a negative coterminal angle. So 240 degrees minus 360 degrees gives us 120 degrees. So we're going to start the x-axis and go the clockwise direction. So that would be 120 degrees. And again, there's an infinite many amount of times we can go around our circle, 360 degrees, positive and negative directions. So there are many other answers. Next example says sketch the angle theta equals 660 degrees in standard position. So 660 degrees, I'm going to first figure out which quadrant this lies in by finding its coterminal angle by subtracting 360 degrees, which gives me 300 degrees. So I know this is 270 degrees and all the way around 360, so that tells me 300 degrees would be in quadrant 4, somewhere about here. So because we've gone more than once around, we would start at the positive x-axis in the counterclockwise direction. So that's 360 and plus another 300 gives us 660 degrees. So that's my angle drawn in standard position. It can be helpful to know some of the frequently encountered angles in one rotation of a circle. Multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees are commonly encountered in many trigonometric applications. As we've shown, we've already been talking about 30, 60, 90 degree special right triangles and 45, 45, 90 degree special right triangles. So that's why we have these angles on the circle here. Become familiar with these angles and understanding how they relate to one another will be useful when we study the properties associated with them. It says to convert each degree to radian measure. So instead of converting them to a radian measure, we're going to learn a trick for this. So let's start off with a degree. So it's going to be important that you know these without using a calculator on this circle, because it's going to relate to what we call the unit circle, which we haven't really talked about yet, what will be. So here's my 30 degrees, and we're using this because it makes a special right triangle 30, 60, 90. So 30 degrees plus 30 degrees is 60 degrees, 90, 120, 150, 180, 210, 240, 270, 300, 330, and all the way around would be 360 degrees. So then if I counted instead by 45 degrees, I would get 45 degrees, 45 plus 45 is 90, 135, 180, 225, 270, 315, and back all the way around is 360. So we can count by either to go around our circle. So let's say we wanted to convert 30 degrees. Well, actually, before we convert the 30 degrees, let's start off with 0. We know this would be 0 radians, or all the way around is 2 pi radians. We know halfway around our circle is pi. Half of pi would be pi over 2. And what if we did half of pi over 2? Sorry, I just wrote pi over 4, which is the answer. Half of pi over 2 would be pi over 2 times 1/2, because you keep change flip, which gives us pi over 4. So half of 90 degrees is 45 degrees, which is, again, in a radian measure, pi over 4. So that's how you can think about your pi over 4s. For down here at 270, we've already said that that was 3 pi over 2, because if you count by 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is 2 pi all the way around your circle. So let's think about counting by pi over 4 around my circle. So if I start with pi over 4, this is 1 pi over 4. 2 pi over 4 is pi over 2. Then we have 3 pi over 4, and I'm just going to change this into pi over 4 in orange. Then we have 4 pi over 4, which is pi. 5 pi over 4, which doesn't reduce. 6 pi over 4 is 3 pi over 2. 7 pi over 4 and 8 pi over 4 is 2 pi. So now I've converted my angles into radian measures without even having to multiply by pi over 180. So 135 degrees is 3 pi over 4. 225 is 5 pi over 4. 315 is 7 pi over 4, etc. So I'm going to erase this. And instead of counting by pi over 4 on my circle, or 45 degrees, let's do 30 degrees. So let's change 30 degrees into a radian by multiplying it by pi over 180. So really this is 30 pi over 180. So those cancel out to leave us with 3 pi over 18. And we know that 3 goes into 18 6 times, so pi over 6. So now I'm going to count by pi over 6 around my circle, and let's go ahead and I'm going to use green. So if I'm counting pi over 6, or 30 degrees, 30 plus 30 is 60. So the next place I'm going to land is at 60 degrees. So this is 1 pi over 6. Then we have 2 pi over 6, which reduces into pi over 3. 60 plus another 30 is 90. So up here we would have then 3 pi over 6, which is pi over 2. So we're just counting 1 pi over 6, 2 pi over 6, 3 pi over 6. Then we have 4 pi over 6, which reduces into 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 we know is pi. 7 pi over 6 doesn't reduce. Then we have 8 pi over 6, which becomes 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 becomes 5 pi over 3. And 11 pi over 6 doesn't reduce. And then all the way around, 12 pi over 6 is, of course, 2 pi. So that was just counting by pi over 6 on my circle. So then I know that 120 degrees is 2 pi over 3 in radians. 150 is 5 pi over 6. 210, 7 pi over 6. 240, 4 pi over 3. So I'm going to erase these values because we don't really use those. We just use them to help us get our values. But it is really good to know these on your circle because we use them very often in upper level math, and understanding of this is very important, recognizing the values. So some other things to recognize. Let's again look at the 45 degrees. So if I make a triangle here, you'll notice that this triangle, this 45 degrees, is pi over 4. And then that if we reflect it across the y-axis, notice that the 135 degrees is also over 4. And 225 degrees uses the 45 triangle, which again is over 4. And then, 315 is also over 4. So all those middle ones are over 4 because they are using that triangle that has 45 degrees, so pi over 4. So that's why those are all over 4. Notice the same thing occurs or happens when you have 30 degrees. So 30 degrees would be this triangle here, pi over 6. 5 pi over 6. 7 pi over 6. 11 pi over 6. All those values are over 6. And then same thing with 60 degrees. Those are all over 3. So in the first quadrant, notice that these are all 1 over the value. So 1 over 6, 1 over 4, 1 over 3, 1 over 2. And in the second quadrant, notice that it's 1 less than the denominator. So 2 pi over 3, 2/3, 3/4, 3 pi over 4, 5 pi over 6, 5/6. 6 pi over 6 would be pi, right? So 1 more than the denominator. Here we have then in the third quadrant, the numerator is 1 more than the denominator, 7 over 6, 5 over 4, 4 over 3, 3 over 2. And the last one somebody told me in the fourth quadrant, 2 times the denominator minus 1. 2 times 3 is 6 minus 1 is 5. 2 times 4 is 8 minus 1 is 7. 2 times 6 is 12 minus 1 is 11. However you want to remember these values is up to you, but it is important that we know how to get these without a calculator. So it is going to be important that we learn these and how to recall them quickly. So I would start by making a unit circle now, and I would practice doing the degrees on your circle at home and timing yourself to see how long it takes you. Then I would practice doing the radian measures, and I would start becoming very familiar with these because these are very important to upper level math in pre-calculus and also calculus. So that is all for today.